Okay, 9.3. We're going to graph rational functions still. However, this time our P and X and our Q and X can be anything. They may not be linear. All right, because yesterday when we talked about them, they were linear. The only thing that has to be true is that Q of X cannot be 0, because otherwise you don't have a denominator, and that can't happen. All right, when we talk about our rational functions, so a fraction of functions, the properties, the x-intercepts are the zeros of the numerator. In this case, we're going to keep using P of X and Q of X as our examples. The x-intercepts are the zeros of P of X. Zeros means you set it equal to 0 and solve it and find it. That gives you where you're going to cross the x-axis. The vertical asymptotes, and we'll abbreviate that as VA from here on out, is when the denominator is equal to 0. The horizontal asymptotes this is going to vary. There's 3 options here. The horizontal asymptote is that the asymptote can be 0. Y can be 0 if the degree of the numerator is less than the degree of the denominator. And degree is the exponent, the largest exponent. It can be the leading coefficients, and that's what it was yesterday. And the reason it was yesterday the leading coefficient over the leading coefficient was because the degree of the numerator was the same as the degree of the denominator, meaning they're both linear, so the highest power was 1. So the leading coefficient over leading coefficient when the degrees are equal. All right. However, there is no horizontal asymptote, or none, when the degree of the numerator is larger than the degree of the denominator. So the properties of this are you can get x-intercepts, vertical asymptotes, and horizontal asymptotes. However, horizontal asymptotes have some variations, and you need to be able to tell what are the degree, meaning the highest exponent of the numerator versus the highest exponent of the denominator. They're either the highest is less, it's equal, or it's greater for the numerator. Gives you those 3 options of a horizontal asymptote. The domain is all reals except whatever we got for the vertical asymptote. And the range, well, that's a little tricky. Sometimes you need to be able to look at your pictures and to be able to figure them out. You may not always be able to figure out your range based on the graph alone of what you do by hand. You might have to look at your calculator. So this range question is going to vary, and it really only comes into play when you can graph a fairly accurate picture by hand or either use your calculator. So we're going to look at several examples here. And in everything that we do with our homeworks, our quizzes, the tests that you're going to have, these are the things you got to find. You need to be able to find your x-intercepts, you need to find your vertical asymptotes, your horizontal asymptotes, the domain, and potentially the range. Okay, so let's look at, first of all, y equals x over x squared plus 1. When I'm starting here, first thing I'm going to do is what are my x-intercepts? The x-intercepts is when the numerator is 0. Well, x is 0, so the x-intercepts are at 0. The vertical asymptote is when the denominator equals 0. And when I set the denominator equal to 0 and solve, I get the square root of a negative, which is imaginaries, and that can't happen. So if that can't happen, then there is none. There is no vertical asymptote. The horizontal asymptote is based on the degree. Well, the degree of the numerator is 1. The degree of the denominator is 2. So 1 is less than 2. And when I look at my options, and for right now you can look, but they are things you're going to have memorized. When the degree of the numerator is less than the degree of the denominator, we get y is 0. Okay. Domain in this case is all reals. There are no exceptions because there was no vertical asymptotes. And we can't tell the range from this. You'd have to look at the picture. After you graph it, you find some points. If you're doing these by hand, and this is going to be real difficult because you have no boundaries, no asymptotes. So to do this by hand probably would not be a true question. It would probably be a calculator question. So let's move on to another one. Y equals 2x cubed over x cubed minus 1. In this case, the zeros is when the numerator is equal to 0. So the x-intercepts are 0. The vertical asymptote is when the denominator is equal to 0. So x cubed is 1, cube root both sides, x is 1. The horizontal asymptote is based on the degree. The degree of the numerator is 3. The degree of the denominator is 3. They are equal. Therefore, it's the leading coefficient over the leading coefficient. Y is 2. Now in this case, I do know my domain. My domain is going to be all reals except the vertical asymptote of 1. So if I were to make a picture of this, the vertical asymptote at 1, the horizontal asymptote at 2, I could pick some points and plot them and find some pieces. But that would give me a good setup and a good start to it. Okay, here I have y equals negative 1 over x cubed plus 1. The x-intercepts is the numerator equal to 0. Well, that can't happen, so there are none. There are no x-intercepts. The vertical asymptote is the denominator equal to 0, so x cubed is negative 1, so x is negative 1. And the horizontal asymptote, the degree of the numerator is 0, the degree of the denominator is 3, 0 is less than 3, and when the numerator is less than the denominator, y equals 0 is the asymptote. So if I were to graph this, y equals 0 is an asymptote, vertical negative 1 is an asymptote, and then I could pick some points and go from there. The last one, y equals x squared minus 3x minus 4 all over x minus 2. So the x-intercepts is when the numerator is equal to 0. Well, that's a quadratic, which means it's probably factorable. X minus 4, x plus 1. So x is 4 and negative 1. Those are my x-intercepts. The vertical asymptote is when the denominator equals 0. And the horizontal asymptote is based on the degree. 2 is greater than 1. Therefore, there is none. There is no horizontal asymptote because the numerator is larger than the denominator. If I were to sketch a graph of this, vertical asymptote is at 2. I have no horizontal. I do know that I'm going to cross at 4 and at -1, and then I would need to plot some more points. The domain of this is all reals except 2. Oh, going back to the other one, the domain would be all reals except -1. Again, the range is something that we wouldn't really be able to find algebraically. We would have to use our calculator in order to do that. But you should easily be able to find the zeros, vertical asymptote, horizontal asymptote, and domain, and that will be expected of you to be able to do those by hand.